University, and I do trust it will be a new stage for our collaboration. COP is the top university in petroleum engineering, and Tsinghua is the top one in every field. So I think UFRG is the top one in South Africa. So between our collaboration, between our two top universities, I think we will step to the new stage for the more successful collaboration, especially the joint research together with the Chinese enterprises in Rio. I look forward to. And I take this moment, I would like to thank Zhejian, Levi, your two guys, and Safel. I think I have not seen him for several years. Your two professors are the pioneer from this Brazil side for the close, successful collaboration between us. And it's by your effort that China, I think, is so successful in the deep water development of oil and gas in South China Sea. And that's why we have 4 state enterprises here who are all successful for the local development of oil and gas together with the Petrobras. So thank you very much. Thank you.
Okay, thank you. Thank you very much, Professor Duan. Then we pass to the next stage of the workshop. We have 2 presentations, one from Professor Mari Silvia about copy, and the other one from Mr. Wu about Sinuk. Then Professor Mari Silvia, please, and have 2 microphones, one each of you. And
Okay, so the idea here is to make a short introduction of our institute. So some of you know us quite well, but maybe some don't know exactly who we are, so that's the idea. And the idea is as well to show you that we have, as Professor Duan said, we have a lot of interaction areas where we can work together. And I'm sure that we can improve the relationship from all those past years and widen the field of collaboration. So I will start here. So our institute is Alberto Luiz Coimbra, and is named after our founder. And the COP was 60 years old last year. So we are sort of a young institute that was created when the research in engineering was not very strong in Brazil. So Brazil was not developing technology as we do today. And Professor Coimbra saw the need of this development, and so he thought about our institute as to be the leading institute in Brazil for research in engineering. So that's, I don't know where to point to. It doesn't work. Ele pediu para esperar. Sorry. technical problems. Okay, go back. So our institute is part of the Federal University of Rio. That is the biggest federal university in Brazil. We are formed by 4 different campi. So here we are at Cidade Universitária. That is the main campus of the university, and the largest one too. But we also have a campi at Praia Vermelha that is in close to the center of the city, and the two other ones outside the Rio de Janeiro city. We are divided in centers according to the knowledge area. So we are located here at the Technology Center, together with 4 other institutes. The Polytech School, that is our undergrad engineering institute, responsible for all the undergrad courses in engineering. The Macromolecules Institute, Chemistry School, that is responsible for courses that are more related to chemistry engineering and industrial chemistry and so on. And NIDS, that is devoted to technology applied to social development. So together with the other institutes, we comprise the Technology Center. This is our board of directors. Professor Susana Kahn is our general director. And I work with her on the technology and innovation director board. And together with also with Professor Tiago Aragão, that is responsible for the entrepreneurship actions within our direction. So I'm also professor at the Metallurgy and Materials program of COP. So this is our main campus where we are located. And I would like to show you an institutional video that will show you a little bit about our installations and our capacities, infrastructure, if it works. I think we're having some. Well, I can keep talking while we're waiting for the video to upload. But COP is comprised by 13 graduate departments on engineering. I think now we go.
A COP ela é um instituto de engenharia, mas a gente sabe que a engenharia implica num conhecimento de várias e diferentes áreas. Isso faz com que cada vez mais a gente precise se tornar multi e interdisciplinar.
A COP vai da engenharia clássica, a engenharia da saúde, a tecnologia da informação, transição energética, mudanças climáticas. Então, são várias as áreas que a COP atua, sempre trazendo contribuições industriais e sociais relevantes.
Os nossos 13 programas de engenharia, eles atuam cada vez mais de uma forma sintonizada e integrado entre eles. E assim, a gente vai inovando e vamos nos antecipando ao futuro.
10 dos 13 programas da COP são avaliados com conceitos 6 e 7 pela CAPES. Esses conceitos eles são dados a cursos que têm notadamente nível internacional.
A COP, evidentemente, não atua sozinha, não atua isoladamente. Nós temos parcerias com diferentes instituições.
A COP tem um centro com a Universidade de Tsinghua, na China, que atua fortemente em mudanças climáticas e novas formas de energia, que hoje a gente tem avançado para questões de descarbonização, biocombustíveis, biofertilizantes. A COP sempre se caracterizou por buscar soluções no setor de óleo e gás. Temos vários laboratórios voltados para estudar os problemas do pré-sal. E agora toda essa expertise está sendo usada na transição energética.
E as tecnologias desenvolvidas aqui na COP, elas podem e devem direcionar tanto políticas públicas para que o emprego dessas tecnologias seja possível, quanto políticas privadas também, para que essas novas tecnologias sejam absorvidas pelo mercado.
Um tema muito importante também que são as cidades, a mobilidade urbana, encontrar soluções que vários programas da COP podem atuar no futuro. Nós formamos 600 mestres e doutores por ano. Nós temos 300 pós-doutores e temos cerca de 700 pesquisadores nos laboratórios para ajudar na solução de problemas que chegarão diretamente na sociedade.
Tecnologias de baixo carbono, economia azul, bioeconomia, aproveitamento de resíduos, economia circular, cidades sustentáveis, são formas que a gente tem de se aproximar do que é necessário para os nossos alunos, para o Brasil e para também o mundo.
São 60 mil metros quadrados de laboratórios, muito bem equipados, modernos, mas são as pessoas que fazem uso dessa infraestrutura e que geram conhecimento.
Só com investimento em ciência, tecnologia, inovação e ensino é que se vai conseguir fazer frente a tantos desafios e propiciar uma qualidade de vida para um número maior de pessoas. Por isso é importante que a COP esteja cada vez mais próxima das demandas da sociedade, de uma maneira que a gente possa buscar as respostas mais adequadas. Quanto mais desenvolvida é uma nação, maior a capacidade dela de resposta a qualquer vulnerabilidade. E é isso que a gente quer para o Brasil.
I think the video shows a lot of data that I'd like to talk about COP, but I think it's much better to look at the video. And one thing that is very important that was mentioned was the relationship with Tsinghua University that started with the Tsinghua University in Beijing a long time ago. And now that we wanted to do the new agreement with the Tsinghua University at Shenzhen. So our mission is, we are an academic institute, so also the video showed some numbers. So our mission is academic excellence. So we really work to have the best professional doctors and masters to be formed at our institution. And to do that, we also use our laboratories. Some of them were showed in the video. We have very, very up-to-date installations for research in the most different areas. We are very, very strong in oil and gas because it's the main economic sector in Rio de Janeiro state, and now we are widening that for energy. And so our students have the opportunity to use all those installations to work with their thesis and master work. And the idea is that we work together more and more closely with different partners, public and private sector, and that we can develop projects with that are applied and that we can bring that to society somehow, or developing new technologies that can be used by companies, or to have our students to create their own companies and apply and make the technology that they develop in the laboratories. We want to increase the TRL and make them, turn them into products. And, sorry. Okay, those are some of the numbers, our numbers, and we have about 350 faculty members, and a total and close to 3,000 graduate students. And we do that, our students, this is on doctoral thesis and master's thesis per years. These are our average publication, and these are our average though. It's the number that we have in projects, research, development, and innovation, together with the industrial sector. Our projects, they are carried through Coptech Foundation that manages all the resources that are that are brought to COP by the companies are managed through Coptech Foundation. And that actually, that partnership between COP and Coptech allows us to be what we are. Eu não consigo passar. Allows us to be what we are because we can have the companies with the that needed to develop new technologies to finance that technologies to be developed within our laboratories. So as I said, and as was also in the video, we are 13 programs, 13 graduate engineering departments working together to develop new technologies in different sectors. So we develop a lot of new technologies for oil, gas, renewables, low carbon solutions, including not only the new technologies, but also all the electrification of those new technologies. But we also have other knowledge areas where we work, such as health and engineering, nanotechnology, and so on. And since my presentation is stacked and I cannot go on with that, I hope I could pass a little bit of what our institute is and what kind of research we develop. And I'm open to answer questions if, and our laboratories are also open to receive any visit. If you want any specific laboratory, we can also help with that. Thank you.
So, yeah, now is Synox presentation. Okay, good afternoon, everybody. Today I'm on behalf of our company and to show and give you a presentation about Sinop Brazil in AD&I. Oh, good. So my presentation, and there are three parts. The first one is Sinop glance, and the second one, Sinop Petroleum Brazil. And the last one is our Sinop's NP's AD&I levy. Sinop, actually the full name is China National Offshore Oil Company, a corporation, the largest offshore oil and gas producer in China, and was established as a state-owned mega company in more than 40 years before. And we have the 5 main business areas. And the oil and gas exploration and the development. This is our core and business. The second one, engineering and technical service. Actually, you know, and Sinop is different with Petrobras. And so Sinop has their own engineering company and drilling company and logistic service company. And also we have refinery and marketing and for the new energy, including the offshore wind power, and also the natural gas and the power generation and finance company. So I will show a video for Sinop International.
We are Sinop International. We have unique perspectives, diverse backgrounds, and varied stories. Today we stand as one team, bound with a shared vision of what is possible together when the best and brightest unite. While our roots were established in China, where today we are the world's largest offshore oil producer, our future is focused on a global front to become an operator, partner, and employer of choice. With operations that span 6 continents and over 20 countries worldwide, we have assets in some of the world's most sought-after basins. Our diverse portfolio means we have the assets, the relationships, and the experience needed to deliver safe, sustainable energy for decades to come. Our power is in our collective and in knowing that together we are leading the charge toward a stable and responsible energy future. At the core of this is our culture, which pushes us to be better every day. And most importantly, our commitment to safety is second to none. Nothing is so important that it cannot be done safely. Deep down, underlying our individual strengths is one common vision: to be a global energy leader and deliver safe, sustainable energy for all. It's a bold vision, but one we are not afraid to face head-on. Together, as one global team, we will harness our culture and experience to grow our production, our talent, and our capability. Together, we are more focused, determined, and stronger than we have ever been before. Together, we have a new sense of purpose and pride. Individually, we may be different, but as a team, we are very much the same. We are Sinop. One team, one vision, energy for all.
Okay, now we talk about Sinop Brazil. Actually, for Sinop Brazil, there are 5 blocks, oil blocks in Brazil currently. And there are 2 production oil fields. The first one is Libra. Second one is Búzios. And you know the Búzios is the largest deepwater oil field in the world. So we are very proud. We are the Búzios' partner. And also for Libra, we hold 10% share, and our partner is Shell, Dow, and CNODC. And for the Búzios, and also we cooperate with CNODC, and the operator is Petrobras. Also, there are 3 exploration and oil fields in Brazil. The first one is Pau-Brasil, second one is ACFO, the third one is north of the Brazil is we call Block 592. Especially the third one, we hold the 100% of the share for this oil field. We are the operator. But I can share with you some information. Last year, we bought 4 blocks. Yeah, and the first one located in Santos Basin, and we hold 100% of the share. We are the operator. And the the 3 oil fields located south of Brazil, and we are the partner with Shell and Petrobras. End of next month, we will sign the official contract with MME and about the 4 blocks. So, and for the Chinese oil companies in Brazil, I believe you know Sinopec and CNODC and Sinochem, but CNOOC is a top 5 producer for the oil and gas production in Brazil. We are top 5. Also for Sinopec and CNODC and Sinochem, and the production is not too much yet from till now. So you can see many Chinese oil companies in Brazil, and also here is for the Sinochem. Sinochem here is our Búzios and Libra, and also here is CNODC, and here is also CNODC. But now, and we hold CNOOC holds the biggest oil fields sharing in Brazil, and between the CNOOC companies. Sorry, between Chinese companies. Also for the NP levy. So, and I believe you know there are 17 oil companies in Brazil, and they have to do some AD&I's obligation according Brazil's law. So, and you can see most of the AD&I projects belong Petrobras, and also you can see from this map, and increased a lot, especially from 2015 years till now, increased a lot. Till also for last year, the investment reached 4 billion reais. Also, from this map, you can see, and currently, from the NP's website, there are more than 4,000 contracts, and in the AD&I based on the NP's levy is a lot. So according the data, yeah, you can see the area from the supply biofuels, so exploration, natural gas, and other engineering sources, and also for the regulation of the petroleum, natural gas, and biofuel section, and also cross-cutting and terms. Also for the executor companies, you can see from the Petrobras is lot, and the second one is Shell, Repsol, Dow, and also all of the oil companies, I believe, involved, and this kind of NP's levy. Also, you can see the executor, UFI Jota, took most of the projects till, I believe it's till the 465. So, and other universities, you can see this is NP's website's data. For the AD&I's research area, according the NP's calculation, and from the explanation and production, and for the engineering efficiency, environment production, engineering transocean, downstream, and natural gas, and most of the project under the explanation and the production. Also for CNOOC Brazil, and I believe currently, at least in these 2 years, we are focused on more explanation and the production area. I will share how to say our research line for you. This is our Libra's research line. So you can see our CNOOC research line follow Libra's because we are the Libra's partner, from the human factory to the HISAP and some carbon molecule service and so deep water lift, also for Libra Digital, and also for the subsea from the riser and the ridge pipe chemical cocktail subsea HISAP, and for the well, also for some reservoir, also especially for our PRM, permanent reservoir monitoring, and also for the oil lifting. So we developed the CTV, cargo transfer vessel. Now, I believe 2 years later, our CTV were launched in the Brazil's market. Also, I will show example for the HISAP technology, because for HISAP, we put more than $2 billion US dollar about this project. This is some project's background. Is a video. Oh, sorry. Could you go back the video? No? Just click the button. Oh, no problem. So I will share. Yes. This project is our benchmark project about the RDNI. Because the Libra oil fields and especially the IPSO is too huge, too heavy, so we want to decrease the IPSO's weight. So we take some model and inside the subsea. Okay, and currently, I believe last years in December, we just signed this big contract. Okay. So for NPS level for CNOOC, I think we did some strategy about the, especially for some for subsea technology, and you can see in the future, and we can see some subsea or electrical equipments in Brazil. I believe the we put 2027 year. I think now for technical side is ready. So also for the subsea power generation, I think you can see previous video. So we try to put some subsea put generation and connect the HISAP project, and also we are developing some net zero emission and a digital manufacturer to optimize our IPSO, also for the reservoir with maximum RF and low emission, and also in the future some autonomous power generation, and so for some production, very completed production. So this is our CNOOC's RD&I strategy in the future in subsea area. So I just share with you. So also for our cooperator, we already signed the MOU with Petrobras, SEMPES about the RD&I project. We already signed some MOU with Sinopec and CNPC. So we will develop some projects together. And also we have some cooperation with, yeah, for sure, the COPI, USP, UFRN, and these universities and some companies. I think so. I think after the Libra and the Bujus, the production become more and more. So our investment will become more and more. Yeah. Thank you. Thank you, everybody. Yeah. This is my presentation.
Well, Sejan, Levi, Sujian, Mary Sylvia, thank all of you. This moment I would like to present something new. And also my first presentation, an open presentation. It's also on the thermal energy. And I think it's also the first trial in China. But anyway, it's only in the development of the idea, you know, the new ideas, and it will be last about maybe more than 10 years to make it true. I think I will talk about very briefly about the background. In China, we have very great challenges for the new energy. We have been successful in the deep water oil and gas, and also China is also very successful in the wind energy, the offshore wind energy, and but for the thermal energy, it's more difficult because we have to take the water from the deep areas, deeper than about 1,000 meters. This is a very, sorry. It's we try to, besides to get the water from the deep waters to the floating structures, we also try to get like the pharmacies, new pharmacies from the deep waters after the development of the new energy. And we also try to make it to be a fishing farm. Like it is indicated that the lobster, if we have the lobster to be in the deep waters, like for example, it's we can have about 1 kilo of the lobster in 1 year. But if we plant it, we fish it on the platforms from the deep waters, the lobster will be growing faster. It will be like 4 kilos in 1 year, same like that. So the Chinese people is trying to make the thermal energy to be applied to the fishing and to the pharmacies, same like that. The problem is, this is just a very simple presentation about the system. This is the floating structures like the semi-submersibles to support all the facilities for the processing of the thermal energies, also the processing of the fishery and also the pharmacy production. Same like that. All those are installed in the floating structures. And the problem is how we can hang on the so long and heavy pipes on the platform to prevent like the heaving or the serious motion of the structures from the waves. And in this way, we designed the top structures besides the floating submersibles. And then we have to design the pipes. It's a very large pipe. The diameter of the pipe we designed to be the 4 meters. It's about 10 times of the oil and gas risers, And then for this part, how to fix the pipes to the seabed, it's also a very challenging problem. And I will talk about the 3 parts. This is the simple presentation of the system. For the top connection, we have like this one for the compensations to reduce the motion of the pipes, And then we try to design a very special connectors for the quick locking and quick releasing. We have to install these so heavy and long pipes to the submersibles, and then we also have to release the pipes in emergency. So we designed this one for the quick locking and releasing, and we also have to, like here, to tension the pipes during the operations. So it's a very special design. For the pipes of the 4 meters diameter, it's also a very special design. We call the multi-layered structures of the different materials. Some materials structure for the strength, some for the function against the fatigue, and for some others, it's very important we have to also to keep it warm during the warm enough to prevent the loss of the heat during the lifting of the waters to the pipelines, to the platforms. Anyway, it's also a difficult problem for the construction, and it's a very difficult problem for the assembly. And then for the last part, the fixed of the pipelines to the seabed, we try to design this system to prevent the dynamics from the pipelines, you know, and we try to how to reduce the fatigue of the pipes. One way is to reduce the dynamics of the pipes, and we found the fixed state of this one pays a very important contribution to the dynamics. So we designed this one to have some this is the specific design of the weight to compensate the dynamic performance of the pipes. So this will have more difficult problems in the analysis of the dynamics. We try to model the viscoelasticity dissipation from the multi-layered structure of different materials, and then we try to model the clump weight we installed along the pipes, to reduce the net weight of the pipes from the the load to the floating structures. And then we have we designed different, a lot of clamps along the pipes. So we try to also model the different clamps. Then we use, I think my students learned from you about the application of the GITT method, right? I think it is from the analysis of especially the heat transfer, right? So they try to use the GITT to solve the equations. This is a very complex equations. We try to use this one to get the solutions. And this is the results of the GITT solutions. And we also analyze the influence of the viscoelastic dissipations on the pipe stabilities and also the dynamics of the system. This is the results. I will not show the details like the influence of the boundary conditions. The fixed state of the to the seabed. This is the results of the different positions, and the influence of the weight of the clamps. And the second problem is about we designed the pipes in different diameters and in different thickness, and also different structures. So how to simulate the non-uniform state of the structures, and also we installed a lot of clamps to support the pipes. So this is our second research, and we'll show you like here. It's the different section of the pipes, and also the different the change of the cross section, and also we simulate the different locations of the clamps. We use also the GITT method for the numerical solutions of the equations, and we also got the results. This is the results, and then we try to present the convergency and the accuracy of such method, and we get the non-uniform influence and the variation of the cross section on the stability and on the dynamics of the system. Okay, this is the polynomial variation of the flexible stiffness and the density, and this is also the differences. Tanjie is the new student. He is coming next month to continue. I think maybe to continue the research, and this is our innovations about the methods of to simulate the dynamics of the system. But also, we have not considered the influence of the inland flow of the water, and we also did not consider the coupling of the inland flow and the current flow together on the dynamics of the system, and we also did not consider the random vibration from the environments, the environmental loads. So this is the latest results of our past 5 years. Thank you. And I also would like the CNOOC International can have certain, to propose certain project to continue the research, and that probably I think I look forward to the success in Brazil first, and then ahead of the China. Thank you.
Is there any question from the students, researchers, professors?
My friend, Professor Duan, is in China any pilot about OTEC at the moment? I mean, is there any project that in a kind of pilot project in progress there?
Our project is the first one, and 5 years ago, financial support both from the CNOOC and also from the local government of Guangdong province. And it is also supported by the Chinese central government, like we call the Ministry of Information and Industry. We call Gongxingbu, and still, I think but anyway, we have not got the project from, or there was no project from the Ministry of Science and Technology. Yes.
Any other questions?
Thank you for the presentation. Very nice and very challenging. My curiosity is because you have to put the pipe very deep to get the cool water. So we have temperature gradient, and if you have studied how the temperature affects all those dynamic effects, fatigue, and things like that on the pipe.
Right, right, and the temperature at the bottom of the water is about 4 or 5 degrees, but you know the environment temperature In the air is about, in the summer channels is about, I think, like 35 degrees. So it's, that's why we try to apply this system to the thermal energy. But as the results show, there is not so much loss of the heat during the lifting of the waters. It's, you know, it's very quick. It's so large a volume of waters, but the inland flow is also, I think, I did not get the data, but it's fast. But the problem is we have to use a very large pump to lift the waters. And the heat problem is not a serious one, as our results show, but the influence on the dynamics of the structures is very serious. And also, I think the problem is about the simulation of the multi-layered structures. It's a lot. It's, I think, at least 3 layers. Each layer has different materials, and we also have a very complex design of the structures. So it's very difficult to simulate the structures by finite element methods. This is a challenge for the stability of the so long structure. Thank you.
Thank you.
Murilo, please.
I thank you. Nice presentation. Just to know if we are organizing in Sobena, the Brazilian Society of Naval Architecture, and some colleagues from our department, the 10th International OTEC Symposium in December in Rio de Janeiro.
Right.
So maybe a good opportunity for you to come along. It's a very famous conference on OTEC stuff. So.
Right. I think your lab is capable of the testing of the so complex of structures, but we really would like to have such a project from CNOOC International. Xuefeng, we are looking forward to your support.
Okay, if there is no questions, we can have. Thank you, Professor Duan.
Thank you. Thanks.
We are going to have 5 minutes of coffee break, and then we continue after coffee break, please. 15. I said 5. Sorry. 15 minutes. 15. Okay, let's start this second block. Good afternoon, everyone. I hope that you enjoyed the coffee break. My name is Milad Shadman. I'm a professor, visiting professor here at the Ocean Engineering Department of the COPI UFRJ, and I'm going to present our activities and research lines in our group, Offshore Renewable Energy Group, on behalf of our coordinator, Professor Sejeng. This is the history of GERO, let's say the timeline. GERO initiated the activities in 2001, and so it's more than 20 years of research in the offshore renewable energy areas, participation in different national and international important reports, including the IPCC, Chapter 6, that was leading by Professor Sejan and another professor from Ireland. And we are doing the part of Worldwide Energy University Network. I put here some actually highlights of our projects during these 20 years. We installed the first full-scale wave energy converters in 2012 in northeast of Brazil, in the Pecém port. And now we are working in the second, actually, I'm trying to find the laser, but okay. Could you please go back? Okay. And the second generation of wave energy converters, which is a near shore wave converter. We are doing some experimental tests of this wave energy converter in Lab Oceano. That we're gonna have the presentation after this one. And since 2017-16, we started to work on the floating offshore wind for deep and ultra deep water, and hydrogen production from offshore wind, and different actually sources like floating solar, hybrid wind and wave energy in offshore areas, mainly for the oil and gas decarbonization. So I would like, during my presentation, I would talk about some actually research lines that we are actually doing currently in our research group. Okay, when we talk about the renewable energy, offshore renewable energy, we are talking about a multidisciplinary research area. So it's actually to have a really go back, please. It's yeah. So we work with different engineering departments at COPI, actually, to be able to actually address all possible aspects involving in an offshore renewable energy system. So this is the figure that we show here, where we used to actually has a partnership with different areas, engineering areas at COPI. Yeah, we are working with the Petrobras, CNOOC, having projects with Petrobras, CNOOC, Total Energies, Furnas, Engie, basically financing our actually investing on our research and development areas, and we have state agencies and actually federal agencies that supporting our students in terms of the scholarship. Yeah, this is basically the main areas that GERO is working on. We can divide it in three main areas. As you can see, offshore wind power. It involves different aspects of offshore wind, including the layout optimization, the coupled analysis, using the hybrid wind wave energy systems, and offshore wind powered oil and gas activities, synergy actually with these activities. The second, let's say, line, the main line is marine renewable energy, which includes the wave energy converter design, include the design and analysis of ocean thermal energy conversion system, the subject that Professor Duan talked in detail in the previous presentation. Floating photovoltaic panels, offshore floating photovoltaic panels, and actually co-located offshore renewable energy that includes putting different source of renewable energy in the same space to have a more efficient power production from these different kinds of sources. And the third actually main research line is offshore renewable powered hydrogen. Is the hydrogen production from offshore renewables basically. We had a project with Total Energies, and I will talk in detail about this project during my presentation. Specifically talking about the wave energy converter, this is the first full-scale prototype that was installed in the northeast of Brazil in 2012. It was a 100 kilowatt install capacity. As you can see, 2 floaters and 2 mechanical braces going up and down and injecting water inside the high pressure loop, hydraulic high pressure loop, to actually drive a Pelton Pelton turbine to generate electricity. It was an onshore because it was installed in the port, and we have the second generation, let's say, near shore, that it's going to be installed actually in a water depth of 25 to 30 meters. This is a smaller system with a specific control system that currently we are testing in Lab Oceano. Talking about the floating offshore wind, mainly we are working with CNOOC. So these are the subjects we are doing in 2 projects that we are executing with cooperation with CNOOC, Brazil. The first one is offshore wind for deep and ultra deep waters, because the idea is to decarbonize the oil and gas activities in the pre-salt region. So this is it's necessary to look at these challenges. So basically we are doing the actually coupled aerohydrostructure analysis and mooring analysis, considering the shared mooring and different materials for mooring to be in terms of economically be competitive and be viable for such a deep actually water. We are working with coupled fluid structure modeling, CFD and finite element, composite concrete steel platforms. This is the main focus of the project. I would say considering the concrete material and steel material for the floating platforms, to have a really in-depth comparison between 2 material economically and technically, considering the constructive method, considering the installation and all the process. So this is, I would say, the main focus of the project. And this is a 3 years project. So the 2 years actually focusing on numerical simulation and this analysis, and the 3rd year dedicated to experimental tests in Lab Oceano. We have, I would say, a kind of unique opportunity here in Brazil, because we have this image, let's say, for our offshore oil and gas activities in pre-salt area. You can see the pre-salt area here, this brown line. We have a really, really good offshore renewable sources in that area. So we have a really good synergy between what we have in terms of renewable energy and the oil and gas activities. As you may know, oil and gas industry is responsible for 20% of the emissions in the energy sector. So it's really important to decarbonize the oil and gas, offshore oil and gas activities. So this local energy production can make viable such a decarbonization. You can produce renewable electricity to feed actually the demand of the oil and gas activities. So this is the scenario what we have here in Brazil. And this is the second project with CNOOC. Corporation. We are talking about the hybrid wind wave solar farms. It's a wind farm, it's a space that you put the floating solar, you put your offshore wind and wave energy converter to produce electricity and take advantage of the complementarity of such systems. So we are deeply studying these systems because these are new systems with new challenges. We are doing from the zero, the analysis, the dimensional actually analysis, sizing, aerodynamic. I can see our group here involving different aspects regarding these two projects. So the we have this partnership with the electrical engineering department. We are doing a digital validation of the process. It means that you produce electricity, you have your demand, and you need to control your you need to manage your power in terms of using batteries or having batteries and gas turbines. So this is the kind of isolated microgrid that you're going to have in an offshore area. So this process gonna be validated digitally using the OPAL RT system, which is a system in a electrical engineering department, LaFi laboratory, that in collaboration with them we are doing this. Shared mooring is another interesting subject. We are talking about the 2,000 meters of water depth. So we are thinking and we are analyzing the possibility of having shared mooring between the different systems to be to have a more economically viable, let's say, system. The same as the previous project. The last year we have experimental test, really challenging tests in Labosiano, and we hope that we could make it in the best way with collaboration with Professor Paulo Tas in Labosiano. Yeah, just having some examples of what we are doing. This is the idea of optimization of our platform. This is the concrete platform with 3 pontoons. We are using concrete material. We understand that concrete material result in a heavier platform. But of course, when you compare the cost of the heavier platform with concrete and lighter platform with steel, we can see that the concrete platform has a lower cost. So we have a heavier platform with a lower cost. There are some challenges. We are studying this. We are trying to optimize this weight to decrease this weight as much as possible. This is the idea here. It's just really simple image, but include different software and different numerical analysis to do this optimization. For example, the thickness of the concrete is an important actually parameter. If we could decrease the thickness, the necessary thickness, we can decrease actually the weight of the platform. We are working on that using some advanced material in terms of concrete to understand how is the limit for our thickness, to understand what is the limit for our platform weight. So this is a really important study and result for us for having a economically viable, let's say, project. This is a construction method of a concrete platform. This is not an easy task. We are talking about a platform with almost 18,000 of tons. So it's really heavy, and we need to really how we can manage the construction process, because the idea is to have more or less 1 platform per week. It's a kind of, let's say, ideal objective to have this kind of system competitive, because when we talk about the offshore wind farm, we are talking about at least 170 units of actually wind turbines. So if it takes too much time, we can spend like 10 years for constructing one wind farm. Okay, I will speed up the presentation. I have 5 minutes. I will finish, I promise, in 5 minutes. Some ideas, actually, this is the process, the design process for our floating offshore wind. This is one module that we our sizing, and it's going to be connected with the mechanical connections with other modules to have almost 1 megawatt floating solar system. This is the idea of our hybrid wind wave system that you can see. There is no commercial software to do that, so we had to actually create an in-house combination of different open source codes to actually run this simulation. This is about the optimization of the mooring system, the concept of the genetic algorithms using for optimization our mooring system. I'm not going to go through the detail. I'm just putting here the titles and the research line that we have inside the project that we have. Actually, this is the kind of different images of shared mooring. We are analyzing the possibility of shared anchor or shared mooring without shared anchor, to considering all the characteristics and have a best design for our scenario in our water depths. And of course, digital twin is the next step that we would like to continue. Is a digital twin that can be actually fitting with the high fidelity, mid fidelity, and experimental tests. Digital twin for offshore wind, floating offshore wind turbines. This is another idea and work that we are preparing some initial results for that. I'm gonna finish my presentation with our hydrogen project. So basically, we have two concepts. When we have the grid-connected offshore wind, so we have a surplus of the energy production. This surplus can be used for hydrogen production, and the hydrogen can be actually stored or can be used directly in the industry. And another scenario is to have an offshore wind farm exclusively dedicated to hydrogen production. So this is the scenario that we consider, a wind farm dedicated to offshore to hydrogen production. We consider all the dynamic of the process, considering the battery, desalinator, electrolyzer, compressor, the power management and control, power control code, the desalinator, electrolyzer, actually the chemical and chemio-electric model, and for the compressor as well. All the systems was combined and created a software. This is the software that we developed. This is the interface that we have that make possible to do technical and economic viability analysis for any region that we have. It's enough to put our environmental data and to have the cost of hydrogen, cost of electricity, and different data and parameters that we need. Okay, I'm finishing my presentation. I would like to ask to put the video, Cicero. This is the last, yeah, this is 2 minutes, yeah. Yeah. It's a 2-minute video that explains the whole project.
O Grupo de Energias Renováveis no Oceano, da COP-UFRJ, em parceria com o Laboratório de Hidrogênio e o Laboratório das Fontes Alternativas de Energia, com financiamento da Total Energias, realizou este estudo no âmbito do programa de PDI da ANP. A viabilidade técnico-econômica da produção de hidrogênio a partir da energia eólica offshore foi investigado considerando 2 cenários. Na produção offshore, a energia elétrica é gerada a partir das turbinas eólicas que capturam a energia dos ventos offshore. A eletricidade gerada é então transmitida para uma plataforma offshore que abriga uma bateria elétrica para armazenar a eletricidade. O dessalinizador produz água doce a partir da água do mar. O sistema de eletrólise divide a água em hidrogênio e oxigênio, e o compressor é responsável por pressurizar o hidrogênio produzido. O hidrogênio produzido é então transportado para a costa usando dutos submarinos. Na costa, o hidrogênio é armazenado em tanques até que seja distribuído. Na produção onshore, a energia elétrica é gerada a partir das turbinas eólicas que capturam a energia dos ventos offshore. A eletricidade gerada é transmitida para uma plataforma offshore que abriga uma subestação elétrica. Cabos submarinos levam a eletricidade da plataforma até uma subestação elétrica na costa. O dessalinizador, o sistema de eletrólise, o compressor e outros componentes essenciais estão na costa. O hidrogênio produzido é armazenado em tanques até que seja distribuído.
Okay, thank you. I have one more slide just to show our collaboration with the Chinese student, with Sinuk. And if you could, pode colocar a última slide meu, as fotos. Só para passar isso e encerrar. Yeah, this is our photos with the Chinese students and Sinuk, the kickoff of the project. Thank you. I would like to invite Professor Paulo de Tarso for the next presentation.
Vou apanhar disso aqui. Funciona para frente, não anda para trás, não? Bota no primeiro aqui. Coloca na primeira. Consegue colocar na primeira slide? Tá, vamos daqui. Vamos em inglês, tá? Good afternoon. Good afternoon. My name is Paulo de Tarso, Mr. Esperança. I'm a full professor of the Ocean Engineering Department and the executive coordinator of the Labossiano. The idea here is to present a little bit of the kind of tests we perform in Labossiano. Well, at first, the dimensions of the Labossiano is 40 meters length, 30 meters wide, and 15 meters water depth. It's presently the second deepest in the world. The first one is on China, in Wuxi. Then you have the middle, more 10 meters in the center. So in the middle, we have 25 meters. And we have 3 movable floors, so you can move up and down. And we have 5 windows. You can see the model test across these windows, like this one here. The main equipment is a wave generator, 75 flaps. You can have regular waves, sinusoidal waves, or irregular waves. We call the C spectrum. You can, of course, have wind as well, so you can see 8 fans. You can have constant velocity or gust spectra, so sudden wind velocity. You have to control it, of course. These are the room for control the current system. So we have to move all the water, 23 million of liters of water, externally circulate outside. So you need big pumps and big motors for that. So here you can control the velocity of this current system. And the right, you can see the galleries of the current system because you can change the velocity in the vertical profile. Here just showing a model test, a lot of sensors for measuring the motion. You can see like ping pong balls, like
in the Olympic Games. The small white balls are the targets of the tracking system. So you can capture the motion of the body just using this optical system. And you can have, of course, the load cells for measuring the forces and impact forces. And you can see in the left the movable floor in the up position. So we use it to make easy the mounting of the test. Let's see, that is a green water test. You can see that's for Petrobras. You can see if there is a big wave that's going to wash the deck, and this washing can damage a lot of equipment. So you have to avoid this situation. We call in English green water events. That's another test. In this case, it's an offloading operation. So you can see in the right the wind system, you have the waves. In this case, we have a control of the ship in order to avoid the collision. That's called offloading operation. This is a test for LNG terminal. So you can see that the movable floor in the very up position because it is in a very shallow water operation. So we are simulating the shallow water, just putting the movable floor in the up position. That's a torpedo anchor. Instead of use a traditional anchor, Petrobras developed a technology to use a torpedo. So the torpedo goes deeply on the ground so it can resist vertical forces. In the up, you can see the torpedo. Anytime, I hope, is going to down. Yep. In this case, we're analyzing the directional stability of the torpedo because they have to go in the right position. Otherwise, it's not going to go deeply in the ground. That's a directional stability test. That's a riser. In this case, we're studying the compressive waves in the riser. When I have the riser connect to FPSO, so the vertical motion of the FPSO can impose a buckling of the riser. So that's a study of the dynamic of the risers. In this case, they are testing a tool for cleaning risers. So this tool is going to involve the pipe and go up and down, cleaning all the incrustations that you have in the pipes. That's a wave energy test. In this case, we are testing the hydrodynamic interaction between the points. That's for wave energy test for LTS, the Underwater Technology Lab. This is for an ocean thermal energy test. This test was performed for Lockheed Martin, the American company, and Petrobras. The idea is to have a big floating in the free surface and a long pipe connecting the free surface to the ground. In this case, was 1,000 meters pipe. Of course, in the scale, 1 to 50, so we have a 20 meters pipe in the lab. So here you can see in the left the long pipe, 20 meters. In this case, we are instrumented to see the modal shape of vibration using hammer test. And the right, you can see the pipe inside the tank. In this case, we are not testing the thermodynamic aspects of the ocean engineer, just the motions of the pipe and the gimbal and the floater. The test performed in Lab Oceano for Petrobras. In this test, of course, we don't have the big turbine. We install a generator using drones and fans to impose the force and the moment. So that's the way that we test it. The present trend of model testing is combining virtual reality, simulation, computational simulation, the experiment, everything put together and see what you have. That is the trend. So we call the real-time hybrid model test. That is another facility. That is a virtual simulation training. In this case, everything is digital. Okay? I don't see it's moving. No? Okay. So we have, altogether with the experimental aspect, we have, of course, computational simulation using CFD. We use, in this case, Star CCM is a software now belong to Siemens company. And there you can see the gridding, some wave resistance results. And now what you call the hybrid model testing. You combine the experimental control system. In this case, we are using a control system to maintain the platform in the middle position. Instead, use a heavy mechanical equipment. You are just using the strings of the mooring system and a control system to maintain the mean position of the platform. So you can see the platform and the motors in connection by strings, and every load cells. You are in real time controlling these motions and the forces to guarantee a mean position of the FPSO. And this is we call the virtual report, because you pick all the results of the model testing and you put in a virtual scenario. So it's make easier for analysts to see all the results. Dá uma clicada aí, Cícero. Não. Esse aí clica, isso, okay. So you are seeing a digitalization of the experimental test. It's not a simulation, okay? All the motions are in fact measured, but we can have a lot of flexibility. We can go inside the model virtually, but using the tested image. So it's a combination of the reality and the virtual reality to have a clear understanding of this going on during the test. It's not a simulation, okay? It's not like the training simulator. That's a simulation. Here is not simulation. It's just a combination of digital tools and reality to give you a better insight of what's going on. And that's it. That's a night view of Labossiano. Thank you very much. These are my contacts. Oh, it's open for questions. No question. Man. One question. Yes, in fact, this model test was used by a Petrobras engineer in his PhD degree, and then used it, I think, is Fluent, and get some results from the tests, put as a inlet of the CFD and compare. And there are 2 papers in the Ocean Engineer. If you want, I can send to you. Okay. Well, depends on the client. After Katrina in Gulf of Mexico, they start to use the 1,000 return period because of the big waves. Well, we can have it 1 year, 10 years, 100 years, 1,000. Depends on the client asking. Well, depending on the place in Gulf of Mexico, around 30 meters, 30, too big. Here in Brazil, around 14, 13 meters. So depend of the sites. But you just can have it. Of course, you have to use a scale for the model testing to accommodate the possibility. But after Katrina, the return periods are bigger and bigger because they have a big destruction of the platforms using the criteria at that time. So they have to change. Okay? My pleasure.
Fábio tá.
Workshop cheio. Pode colocar no primeiro slide de novo que não está. Não volta. No primeiro.
Okay. So good afternoon. My name is Fábio Hochleitner. I'm on behalf of Luiz Landau, Professor Luiz Landau, General Coordinator of LANCE, the Laboratory for Computational Methods in Engineering. So I'm a research meteorologist and research at LANCE. I coordinate the Earth Observation Group there. So I will present some initiatives for offshore energy in LANCE. So I will pass by this. All of you know the Science Park this time. This is LANCE for those that couldn't be there in the morning. This is the building across the street. This is the aqui. Não. Está funcionando, não? So, LANCE has several research groups like computational mechanics, earth observation, environmental modeling, data science, geophysics modeling, and scientific visualization. Basically for offshore energy and environmental studies, we have 3 groups that are integrated, like earth observation, environmental modeling, and scientific visualization. We have our team is composed by engineers, meteorologists, oceanographers, geographers, data science, and geologists too. There are several, you have some partnership with spin-offs, startups that born at LANCE, like Comet, Oil Finder, and Geospatial. This is some example about the work developed by the environmental modeling group. We have several studies in all the coast of Brazil. The Earth observation group, we have some satellite systems to receive new real-time satellite data, drones, and maritime radar, X-band maritime radar, to detect and monitoring oil spill. This is the scientific visualization group. We have some facilities there. Like this one, I will try to, again, for those that couldn't be able to see our facilities in the morning. This is one of the sensor, the maritime radar, meteorological stations, oceanographic sensors, satellite data. So here is Lance, the main entrance, and the scientific visualization center. This is a cave, a 3D cave. You have these tractable glasses that you can be in a space that you could interact with or 3D data. This is a multisensorial domo. We can see have a global view of 3D data or 2D data. So you can split all this information, and a holographic screen or holographic display that you can see all this data in 3D. Some simulations about topography and ocean. This is the Lobo Carneiro, high performance in computer. So you have 226 teraflops that you can use to process the environmental data. So all this facility has an objective to integrate all this area, and this studies about atmospheric ocean modeling, Earth observation, scientific visualization, environmental modeling, to build some knowledge to society. Some other initiatives in meteorology, nowcasting and shortcasting for the shore, for the coast, and offshore studies. So you can develop some diagnostic, use the orbital and in situ data to produce diagnostic, forecast, decision, and communication in this level of a temporal level of anticipation. Solar potential and marine and aerosol modeling. Too. Some examples about the satellite data that we receive here. The maritime radar. So this is the integration of these objectives and all the data too. We have a partnership with our center. The Atlantic International Research Center. It's an initiative of Portugal. So we can develop some studies to downscaling and study the South Atlantic region. We have a partnership with other institutions in Universidade Técnica de Lisboa and so on. So we could. This is an example of the using the Earth observation data and environmental modeling in the Amazon region to monitoring oil spill in the Solimões River and the Amazon River. So you can integrate all this satellite data and modeling, atmospheric and ocean modeling. Another example, but in the coast, in the mouth of the Amazon River, This is another project to develop and understand the coastal process of defining the oil spill vulnerability of mangrove forests. So we have this project to integrate all this data to understand the vulnerability for mangroves in the coastal region. There are a project called the Costa Norte in partnership of Enauta. It's a company, a company here. Some projects, just the platform for dissemination data. Just the data, all in real time, and for the forecast for spill and ocean data too. There's several. And calculate. It's another initiative, but a local initiative for Guanabara Bay. We have a platform for monitoring observing this region of Rio, that we can integrate all this data to produce results for applied to transportation, marine life, fishing, airports, mangroves, ports, and sports. And another example for the products that we developed for this project. This wave high, some tests for the oil dispersion, oil spill, simulation for this that run every day. So another initiatives in partnership with Gero about the applications in ocean energy in this region here in the metropolitan region of Rio, in Guanabara Bay and coast here. Another example of studies in the oil spill accident that occurs in 2019, that we have a huge oil spill in the northeast of Brazil. So you can calculate and using inverse modeling to create some probabilistic scenarios for located where the oil start to spill. So you have some probability maps to locate the probable area that the oil start to spill. Another example, including satellite data and locate some possible areas. Another example, now to create operational atmospheric and hydrodynamic downscaling system for the southeast region, and other projects with Total Energy to create a wind field for offshore region using downscaling and integration, combining some satellite data, high resolution satellite data and numerical modeling. It's another project to integrate this area. Some papers and studies that we published with Gero and in this area of studies, located and downscaling. All these projects is to integrate all the satellite, all in situ orbital data, modeling data for downscaling and create high resolution data for offshore regions. Another project for the and this one is for solar potential, and again integrate some data in situ observational data and modeling data for solar potential. So that's it. Thank you very much. Some questions? Any questions?
Ok, thank you, Fábio. Eu chamo... Ok. Professor Bimbim, please. Yeah, you can go.
Very good afternoon. So it is my pleasure to be here. Actually, this is my first time to be Rio de Janeiro, but actually my first time to South America, even. All right. So this university from one of my co-worker, and she graduated from the school and joined the Bureau Veritas Rio as an internship in 2001. And she soon is relocated to Paris and worked for hydrodynamics in R&D department. And she was later relocated back to Rio to lead a team of technology and research. At the same time, I was in Singapore to lead another team parallelly in Singapore to support the Bureau Veritas R&D. And later, he was relocated to North America in U.S. Houston, and quit to join Principal Power. And recently, he was rejoined the BV, and now she's is a vice president of Bureau Veritas, leading BV solution. Her name is Flavia Rezende. I don't know if you know her. She's a very excellent hydrodynamicist, all right, from your university. So from that time, I know this is a very good top university in this country, and the ocean engineering department is one of the best in the world, all right? So I'm very happy to be here. Now it is 4:20 in the afternoon here, the local time, but this is probably 3 a.m. in Beijing time. So I feel a little bit sleepy. So later, if I speak something wrong, please correct me. All right, so today, I'm gonna talk about the shared mooring for floating wind turbine. And I think Professor Milad just mentioned about this topic. So this is quite a specific topic, all right? And I must assume everyone here, you know what the mooring system is. Otherwise, I cannot continue. All right, so the motivation and why we need to put effort in this kind of analysis or R&D is just for one purpose, is a cost reduction. All right, I'm gonna try to use this remote controller. Oh, some words about myself. I graduated from Tsinghua University in, well, 20 years ago. And I get my PhD degree from Harbin Institute of Technology. And later, I did 1 year postdoc in Singapore, in Nanyang Technical University. And then I started a long service for Bureau Veritas. I was relocated to different places, like Paris, like Perth in Australia. And, but majorly, I stay in Singapore. All right, and I was the research director in Inovateca Offshore Singapore before I joined the Tsinghua University 2021. Okay, I serve as associate editor for journal OMAE and some other editorial board member for other journals like Ocean Engineering and some membership for some other conferences. So actually, I did quite a few engineering projects, and some of them is quite related to Brazil water. So I still remember one project from Juyong Shipyard. They asked me to do something for Libra FPSO, because just now we mentioned the CNOOC, they did something for Libra. So if you look at the photo of Libra FPSO, it's actually the width is like 50 meters, but before it was converted into FPSO, it's just like 38 something, because this is a Panamax size ship, all right? So because they increase the width, they increase the volume, and they ask me actually to to check the dumping from the bilge keel. If we needed to increase the size of a bilge keel, then to reduce the roll motion of the vessel. And another one is we did is 10 years ago, like 2014, and that is a project for P33, which is a quite old FPSO. And according to the local law, something that people, that workers, they cannot stay in FPSO. They have to live in another vessel, so or semi-submersible. So that is the first time we propose to use a molar hull. It's actually a accommodation vessel, but it's not a semi, to be stay alongside FPSO, which could be dangerous because they're quite close to each other. And we know that the molar hull, the safekeeping, the hydrodynamic performance is not as good as semi-sub. So we needed to do some analysis. And we did the model test in Marine Tech, and Petrobras sent their engineer to supervise. All right. So some background of the motivation why we do the shared mooring and the D for floating offshore wind turbine. But there are some background information. But only 20 minutes, I cannot go through all the information. But this photo, this slide, shows that we have probably a lot of potential to unlock the deep water, and we're going to use a floating wind turbine to do this. All right. And the second slide shows that in China, recent years, we have quite a few pilot projects related to the floating offshore wind turbine. And the latest one is Mingyang Ocean X. This is quite special, as you can see that they have 2 turbines. All right, this is the latest one. And the levelized cost. So the cost for the floating wind turbine is quite expensive. What we need to, we have the concept is that if we consume, if we use the electricity that is generated by the floating wind turbine, could be 5 to 7 times of the price for the electricity from the fixed offshore wind turbine. So the price is totally different. All right. So this is an idea. So that's why when we analyze how we can reduce the cost, and we found that actually we need to reduce the mooring cost, because the mooring cost is probably 20 to 30 of the total cost. I mean the capex. So if we can reduce the cost for the mooring system, that probably we can reduce the total capex. All right. So this is the motivation. So related to this, probably we need to mention 2 concepts. The one concept is shared mooring. This is the topic of today. And we actually have another concept, which is called the multi-turbine floater. They were like 20 years ago, we already have this concept. It's not a new concept. It's already 20 years. So, but later we think to build that big floater is also not economic friendly. So we're going to think about shared mooring. So shared mooring, what is the feature? So its concept is quite simple, because the cost is from the material that we use for the mooring system. If we can use one mooring system to connect 2 floaters, because this is quite different from the oil and gas, because oil and gas, we probably have 1 FPSO there, but for the floating offshore wind turbine, to develop a wind farm, we probably need quite a few floaters. That gave us an opportunity to use this kind of concept. All right. So as you can see the photo here, the line, the mooring line here is actually connect 2 floating wind turbine. So what is the problem of the design for the shared mooring? So I have summarized some of them in my opinion. The first one is a multiple modal. So this is according to the structural dynamics. So there is an example. So this is the mooring design. How we go back? This is a mooring design for a single floating wind turbine. We use 3 mooring lines. This is the traditional design. And then due to this mooring system, and the platform has a lateral period. All right? Let's say the lateral period, we assume it is T0 is a lateral period. This is a very big period. It's normally it's like 2 to 3 minutes. It's like more than 100 seconds. All right? Then if we think about now we're going to connect the 2 wind turbines together and use the similar concept, but there is one line is shared by two wind turbines, which is the line in the middle. So in this case, and if you are familiar with structural dynamics, then we may have some other model shape, so something like this. There are 4 different. If we just consider the horizontal motion, and we have more model, and then we probably have some frequency, or we see the period is smaller than T0. This is according to the this one. And also we may have some period that is larger, much larger than the T0. So this is one issue that we haven't have it for the traditional mooring design. And another one is transient effect. If mooring line in the center was broken, and what's going to happen to the safety of the other 2 floating wind turbines? This is also another issue. And the snap load. Snap load is a quite special effect that when we have the rope can go slack and then suddenly tight, and then we may have the snap load. This is quite dangerous for the rope. And this could happen for this kind of design, because this wind turbine, if we look at this mode, these 2 floater can go this direction. So when they go that direction opposite to each other, and we may have the problem for the broken or sudden failure of the shared mooring line. All right? So what is the engineering challenges? According to my experience, as I already said, complex behavior of a global performance, and what is the design redundancy? Design redundancy is because our idea is to reduce the number of mooring line used in the design, but how is the redundancy? Later, if we have one mooring line broken, is the system still work or cannot work? All right? And some other unknown failure mode, or we don't have even any rule like ABS, DNV, we don't have any rule that means current mooring rule does not include this content. All right? And we don't have the specific analysis tool. If you use Alcaflex, if you use some other Aqua or those kind of commercial software, you may feel difficult to analyze this problem because you do have so many different kind of analysis method already in the software. All right, and some other things. So design compromise. So we design a mooring system that could be quite complicated. There are several things and factors we need to consider. So I cannot go all the detail, but this is if you are a mooring engineer, you know this is everything, all the things we have to carefully consider in the design. So what is the particular consideration in the design for the floating wind turbine and shared mooring? The first one is we need to consider the dynamic power cable, because if we use the shared mooring, we probably have a dynamic power cable installed between 2 wind turbines, and then you can think about the 2 ends, they are both dynamic. All right? Then what is the problem? The problem may be we have some special fatigue problem for the floating wind turbine, and actually floating wind turbine, the dynamic motion is actually more excited than the normal oil and gas platform. So we may have some other additional or extra fatigue problem for the cable. And for the mooring design, as I already say that the redundancy is one of the issues. The other thing is we probably have more fatigue damage. And another very important problem is to analyze the floating wind turbine using our PC is about, if you wanted to analyze a 3-hour simulation, probably use just, we assume we have the PC, normal PC. You have to use 3 hours to run 3-hour simulation. But in case that your model have like a 12 or 20 wind turbine, and you want to consider everything hydrodynamic and combine or coupled with aerodynamics and the structural dynamics, everything together in a coupled or very fine model, and probably you really cannot run all the state that the design require you to do. All right? So you must be very smart how you think about the methodology that you're going to use for it. So 3 things, I think this is the limitation to design the shared mooring. And also, if you look at the internet world, you can find the design currently include those kind of things. So those kind of design, I think they have some problems. There are mainly three. The first one is redundancy. If you look at this design, the problem is if the mooring line in the middle was broken, then we lose the mooring system. And there is no mooring system for each one. This is the redundancy problem. The other one is extendability. Extendability is something like this one or that one, they design only for this particular pattern. All right? And the other one is too complicated. The design is like this. You can design this, but which contractor will go and install the mooring system like that? No one. All right? So what we, Tsinghua University, what we propose is a mooring system, shared mooring system. We call it a Grand Trine. Grand Trine is a quite simple, straightforward concept. And this concept has a basic module, which is like this. Grand Trine is a triangle. So this concept is particularly designed for the floating wind turbine, which also have the 3 columns. So this is a triangle, and this is another bigger triangle. So this is the basic model of this one. And some use the shared line, and this is shared line. The 2 floating wind turbines share this line. And some anchors is also shared anchors. So this we already get the patent, and this is the first patent of floating wind turbine shared mooring in China. And due to the emergency, and we spent only 1.5 months to get this patent approval from the very initial proposal to the authority agency. And for the other similar concept, the clean similar concept is still pending. We just use 1.5 months to get it approval. So some features of this concept, because we can easily, according to different shape of your block, and we can have the radiation type and L-shape type and other type. So I cannot go too many detail. And as I said, it's quite complicated if we just use the very fine model to simulate everything. So we, in the whole design process, so we need to use different methodology that in each deep methodology, and we actually balance the precise or accuracy requirement and the efficiency. That means for different objective, we may use different methodology, from the very simple, the linear mass spring model, to the very complex, fully coupled dynamic model. And we don't use other commercial software. Tsinghua University, my group, we actually develop our own software, which is called the Kraken, which is a multi-body floating structure analysis software. And I cannot go all the detail of the software, and this is all the modules that we have. And to make a software is always very complicated and difficult. But the validation, related to the accuracy, and the engineering example, that is adaptability of your software. And you also need to consider how to add some new application, like the shared mooring design in your software. They are all important to a software. So, sorry for the Chinese. So the software, we just get the verification by Bureau Veritas, and we get the AIP. After I come back, I will go to Shanghai, and they will have a ceremony for issuing this certificate to me. All right. So, but frankly speaking, there are probably a lot of in-house software developed by the university, but the develop that you can develop to this level in the university as an in-house software is quite rare, And some other things about the design. So in my methodology, and there are 7 steps. The first step is to design the layout. That means include some very important parameter is what is the distance between 2 floating wind turbine, and we use a very simple mathematical model. It's a mass spring model. And the second step, we're going to design the lie profile, and which means we already have the stiffness that we designed in the previous step, and then we think about how we can use the material and to match that stiffness. And there are quite different parameters that we, like you can see here for the shared mooring, and we can have the lie here, and to add some clump weight, and we may have the buoy, and if we have this buoy, we may decouple the motion interaction between the two. All right, so there are different, it's case by case. Then is a preliminary global analysis, and we're going to use a quasi-dynamic method that we cannot use this in the commercial software. And we simplified a lot of dynamic things, all right, and to speed up the computational time, all right. And we also need to check the lie damage, and then the fully coupled analysis, and this is in the software. And because there are a lot of floating wind turbine, if we use the very fine model, like for the mooring line, we're going to use FEM model, and for the turbine aerodynamics, we use the BM model, and for the tower, we're going to also consider the flexibility, and then there are so many still very, very time consuming if you use. So what we are thinking is a sub-model, because as I said, this is a modular design. We just take this one out. We just apply the best model to this model, and then we apply the boundary condition that we acquire from previous analysis, but only focus this part, and we can do the very fine model and its simulation. And transient effect check means this is important, and we need to disconnect suddenly, and we're going to see how this platform can go how much far, and what is the extra load due to the breakage of this to the other mooring line. All right? So fatigue assessment is also important. Of course, it's quite time consuming if you use time domain, because there are a lot of fatigue state to consider. And conclusion, because what I mentioned today in this presentation, it's also the beginning to investigate this problem for us too. So there are a lot of things and very good potential for this kind of a concept related research in the future. So I think I skip this page, and this project is funded by Made Funding, and last year we get a government funding. I think that is the first funding funded by the government to support shared mooring of floating wind turbine in China. All right, so that is all I want to share with you. Thank you very much. You have any question? Yeah.
Thank you, Professor, for the presentation. I would like to ask if you considered in your project the influence of wake propagation behind the wind turbines and how it would impact the design of a shared mooring or shared anchor.
Actually, we didn't consider this. So we didn't consider this. For the wave, we didn't consider because if the two structures, they are too close to each other, and there are interaction between two, and the wave is changed because it passed by a big structure, but this floating wind turbine, they are 1 kilo from each other. So we consider this one and this one, the incoming wave, they are the same. All right? Weak, yeah, not wave, weak, right? Weak, that is we gonna consider, but not right now in our software. We haven't built this, but in the future we're gonna consider it. But how is the effect? I cannot answer you without any results. But we will consider this. We tow back to shipyard, but best we won't expect to do anything because that is increase the cost. So I think for the very first time we make the concept to be real project, and we cost a lot. We are not very sure is it possible to reduce this significantly, but even when we do this kind of analysis, we call the performance analysis. We must have another model, which is the cost model, and when we design it, we should integrate the two models in the same optimization. Otherwise, we lose it doesn't make sense. We design that very complicated, as you can see. It doesn't make sense. It doesn't reduce the cost. All right.
Are you considering which water depth in your analysis? Yes.
We basically think about 100 to 200. Yeah, just something like this. But a lot of pilot projects in China, they even do floating wind turbine for 30 meters. Quite challenging, especially for that dynamic cable. They have to make a two-wave, lazy wave cable, right? So between 100 to 200. This is a target, the water depth.
So we are not considering
That's very important. So to reduce the weight, we don't talk about the cost. We think about the weight we need to use. The fiber rope, polyester, we need to use especially for the shared mooring line between the two floating wind turbine. We're going to use that. This is my initial thinking. But we need to be very carefully when we deploy this. We're going to, and in the future, we need to be very careful, and because we have transferred the offshore support vessel to do the maintenance, if they heat the fiber, we get some big problem. Yeah. Yeah. A fish. Oh, I don't know, fish can bite or. Ah, okay. That is dangerous. Yeah, that is dangerous because it's quite close to the surface. Yeah. The technical challenge.
Thank you for your nice presentation. I have a question. You are using a software you developed. So usually for mooring, you use Morrison equation for calculating the loads. Okay. But I mean, in terms of the hydrodynamic loads, you usually use Morrison formulation. Okay. Okay, and did you consider the vortex-induced vibration? Okay. And the last one is, how do you validate your software solution? Did you compare with any experiment?
Bureau Veritas help do the blind check, and as I mentioned just now, we just get the approval from the Bureau Veritas, and the issue as certificate, the approval in principle. And in that principle, they check all the models, like I said, the catenary model, the FEM model for the flexible structure, and the coupling function in the time domain, and they check everything. And different applications. We use it for FPSO, we use it for semi-sub, and also for spar. And so we also offloading, and side-by-side offloading, we involve two floating bodies. And those kind of application, they also check for us. Yes. We compare, but what we can find is still quite limited. And another thing is the model test results that publish, we just have part of them. We cannot have all of them. But if you do simulation, and what is important to check, if you run your own FEM analysis, you can compare the bending and tension at different loads. But you cannot get this from the model test. Thank you very much.
Professor Yutao, okay. We can go here or we can.
Thank you. It start with the date, 2024. Yes, this one. Hello, good afternoon, everyone. Yeah, it is this one. I'm Yu Tao Guo from Tsinghua Shenzhen International Graduate School. It's also my first time here to be Brazil, also my first time to be South America. Actually, I want to be here for long, and I thought I get a sudden chance just last month. He said we could have a chance to have a communication in South America and Brazil. Of course, it's my if I want to go to South America, Brazil will be my first destination since I nerds something or from the movie or from other place. I didn't have a colleague like Bingbing Li, but I just I want to be here a long while ago, and I named this my presentation here: structural engineering towards high performance and green goals. Today, because I was doing my domain domain R is in mostly in the field of structures, construction materials, and infrastructure infrastructures that's relevant to hydraulic dynamics. So I will display more general topics and ideas in this field, not go to very details considering the joint backgrounds of the audience. So here's something about me. I graduated from Tsinghua University to get my bachelor degree in 2015, 10 years after Professor Bingbing Li. So he's my other schoolmate, like 10 years ago. And also I got my PhD degree in Tsinghua University in 2020. After that, I went to Imperial College London for 2 years postdoc. All this research background about structures and construction materials. In 2022, I went back to China, Shenzhen, to Tsinghua University to join Tsinghua SIGS. So it's this general background of me. So I'm doing in a more specific field in structural engineering in composite structures. And also in composite structures, we need to consider different materials like the steel and the most common one, steel and concrete. And also in concrete, also in steel, we can consider some green materials inside of it, and we use ideas of composite structure green materials to make in the usage in the background and in some things in ocean engineering. Later on I will say that, and also do something about disaster prevention. And in most recent research, we have also utilized AI edit some methods to help our research. So this is the outline of the presentation in 5 branches. First of all, about the composite structures, it's like relatively new in the field of structural engineering, but the history is also very long. It's like traditional structures we consider in infrastructures. It's like reinforced concrete structure and steel structure. So new option is composite structures. It's like combine the advantages of different materials. It's to face the demand of smaller pollution, less resource and less labor, and high strength and fast construction and large span, and also by combination of different one advantages of different materials, it has better performance, like in seismic performance, and also other dynamic performance like that. So this is a basic idea of composite structures. This is like for the steel, it's good in tension, but it has the problem when under compression, like buckling, and it has light in weight, but it is more expensive. But for concrete, it's better in compression, but it's has poor performance in tension, but its weight it has more weight, but it's has less cost. So if we put these different materials in different part of the structure, like this is the composite beam, like put the concrete in the tension side and put the steel in the tension side, it could achieve the effect of 1 + 1 larger than 2. So this is initial and original idea of composite structures. Based on this idea, we have developed different type of composite structures. So this kind of steel plate, concrete steel structure, is what I was doing more in this field, which means we could have one steel plate, which is called steel concrete structure. Also, we could have multi-layers, like 2 steel plates in the outer side and 1 concrete layer in the middle side. This is called steel concrete steel composite structures. So by combination of 2 different materials, we could achieve high performance, like high capacity and rigidity. And because the thick concrete layer, it has higher blast blast resistance, and because of the steel layer, it has another leakage resistance. And because it's a 2-dimensional member, so it can have complex stress adaptive, and also it's fast in construction, because like in the SCA structure, we could use the steel plate as a mold, like the steel is all in the outer side, and we could pour the concrete inside the steel mold. So which eliminates the stage of concrete curing, and also it could be sometimes the developed knowledge technology to pour concrete with the floating steel structure on the sea, so it could save the place. And also, in this study, we need to face key technology change, like interfacial interaction, because two different kinds of materials. We need to consider the compatible deformation in this structure, and also some local and global stability issues. And other type of composite structures, including composite columns and concrete, some steel reinforced columns, which concrete inside or concrete outside, and also this composite steel plate composite structures. And it has usage of buildings, bridges, and also in some underground projects and tunnels, and some protection structures, missile launch structures, also ocean engineering in some floating structures or some submarine tunnels. And this kind of structures and different types of has been promoted in China for more than 27 provinces, and have reached the benefits of different aspects. And also in other sides, the ocean engineering and ocean strategy has become more and more important in China, and it was our one of the most important tasks in recent years due to the marine resource and marine rights. And for composite structures and structural engineering, we could put this knowledge and this relevant techniques into different aspects in ocean engineering, like coast protection, sea platforms, marine factory, some marine power plants, something like that. And another side is about this is about the green goals of China, which is called carbon peak and carbon neutrality. And this is another strategy or important tasks we are challenged. So we are also in the field of engineering or civil engineering. we are doing more things related to the green growth of carbon emissions. And this is something about if what is like the carbon emission like in structural engineering. So if we use the new technology, we could, if we like to make better structures and to enhance the life cycle assessment and to reduce carbon emission in the production process, like steel and concrete and other construction materials, we could like to be an important role in the process of the dual carbon goals. So this is like 4 processes we can do to save, to increase duration, and to decrease carbon emission, and to use recycled materials in the design of structures could help to realize the double goals. This is like the basic challenges to ocean and civil engineering, harsher natural conditions, and more military backgrounds like blast and impact loads, and limited local building materials if we want to do more things in the ocean environment, and green sustainable development and the demand. So using the idea of composite structures and using novel green materials in this process could offer more effective solutions. Some applications in this process, like say crushing bridges, this is a composite bridges in an HCMB project in China, and we have utilized this kind of technology in the world largest bridges in China in the Great Bay Area. And also submarine tunnels is like the first submarine tunnels, Shenzhen Zhongshan Passage, which has just finished in this year, also use these composite structures. Some submarine under submarine space storage or other kind of use. And also sea platforms like floating structures, like in previous presentations, they are saying and using different composite structures like Milad says. So this is potential usage of this new kind of structure. And also some sea platforms and floating islands is some ideas we proposed, and we have also do some researchers in this field, like the fixed platforms or floating platforms, using it as part of the members in structures, and also some joint type on some basement. So this is also the test previously conducted in the lab of Tsinghua University, and we use this composite structure to design the joint of the wind turbine. So I'm going to talk more details of what my group was previously doing about SAS tunnel and also some green materials in concrete filled steel tubes. So we have done some researches in the Shenzhen Zhongshan link, which is the widest one currently in the world. It's like more than 40 meters in wide, and which just opened in April this year, which links the Zhongshan and the Shenzhen in the Great Bay Area. And so we have done some tests and theoretical researches and also numerical simulations in this project. So it's like back in the year of 2016, this project has been launched, but previously in the research stage, which so after 8 or 9 years, so it's finally finished. But it's like this project was funded by a lot of funders, it's like the key research development program of Guangdong province, and also the 13-5, and also National Science Foundation of China, and also other funders. This is like the general structure of this tunnel. It's like it's 6.8 kilometers in length and about 40 to 50 in west. It has the changing variation branch in this tunnel, and it uses structure type of steel, concrete, and steel. structure just here. And the left one is a whole section, cross section, and the right one is a more detailed configuration of the structure. So it's using the steel plate in the outer and inner sides and a concrete poured into the using the air pouring hole in the process, and also it's using the steel plates and steel stiffeners in the surface of the steel, and use the steel waves to collect the outer and inner flanges, and using these steel flips to create higher resistance of shear force. So it's the first subsection installed in 2021, and like I just said, 2024 is all finished. So this is something we are doing in this. I'm not going to very much details. And some similar projects in this field in China, we have attended, like 3 tunnels, 7 bridges, and 2 buildings. And also, I'm going to talk some thing we are doing in about green materials. This one for this basic one, what I was doing in Imperial College London. Like we are using recycled rubberized rubber particles from recycled tires to produce rubberized concrete, and also using this concrete because it's using waste materials. The concrete strength will be kind of low, but since we induce rubber particles, it has a better property in expansion. So we put it into a steel tube to make it like a rubberized concrete filled steel tubes. Then we have studied the monotonic and cyclic properties of these structures. And yeah, some different things we are doing in this project, like different concrete forms and recycled materials, rubberized concrete, and I use geopolymer as a no carbon materials, also inside as a component in concrete, and consider different node cases and consider different members as some articles we have published. Also, I'm going to talk a little about what we are doing right now in the labs of Shenzhen. So considering the past we have done is about the composite structures and green materials, so we are putting these efforts in ocean node case and consider the green goals and also multi-disciplines and demands. We wish to develop composite structures systems in ocean engineering to face the national strategy and regional demand. So this is what my group, what we have now. We have postdocs and PhD, several PhDs and several masters, and it's developing group. Some major topics. The first one is composite structures in ocean environment, like to develop fixed or floating structures in this branch. The second one is green materials about ocean engineering, like what I said, the rubberized concrete, geopolymer concrete, and other recycled materials as component building materials to put them in different structures in ocean engineering. Second one is about AI-aided computing analysis and design. These are some things my group and my students are doing. First one is about to like to use composite structures to improve the performance of fixed platforms, and with some case we are undergoing in China to reach a higher performance and lower cost. There's some research we are currently doing, like to use a composite joint and using hollow section composite members to replace the columns. And also, we are doing composite floating structures. Recently, we are doing like from the most simple one, a composite box with using steel plate as the outside and a composite layer inside, to study the basic performance of this kind of structure, and also try to utilize it as basement of a floating wind turbine in our research. And also, for the green materials side, we are using engineered geopolymer concrete and to study from the basic study like how to create the material to measure the performance and also the current emission of this material. And one direction about the green material is to using recycled material like seashell powder and risk hash ash to create a greener concrete and to use it in principles of composite structures. There's some researches and some tests we are doing. And the third branch about the AI-aided computation, like AI for earthquake, we are using AI tool to recognize the seismic singular, like to identify the basic parameters, like and also use it in early seismic warning, and also to use AI tools to predict the performance of different kind of structures. This is like a structure of multi-layer referenced concrete frame structures. This is a basic framework of this part of research. And also AI can also be used to like identification of failures and damage. We are using large model in the recent research to identify the cracking behavior of concrete, and we proposed a structure called crack SEM, which SEM is for segment analysis model. It's like the first large model used in this identification area. Also, we are doing a research like using AI. AI is good for topology optimization in other in structures. Like this is a new study here, and we want to use this technique for the topology optimization of the fixed platform of a safe platform. So some prospects. Now we are in Tsinghua SIGS. It's a place for study and research, and it's in a great Bay Area in China, and we are facing the great challenges of engineering and great demand. And also now our school is international graduate school. We are targeting to have more international collaborations and more collaborators and more competitors with multidisciplinary collaborations and innovations. And also the Great Bay Area, and it will have a lot of demands, like different infrastructures and different equipment. So we hope to, using our techniques and more collaborations, to create our and finish our goals in recent future. And these are some collaborations with industries. Also, thanks for listening. For more info, you can visit here. This is my website, and also you can scan the QR code. It's also the same link with the website. Thanks.
Thank you, Professor. Is there any question?
Very nice presentation. Yeah. I understood you are trying to do the design combining steel and concrete. In fact, we have been for a long time here studying fiber reinforced cement for subsea applications, like sandwich pipes, and now we are considering possibility of floating wind turbines, the base of these turbines. Have you been some experience in your group about these fiber reinforced cements?
I can just roughly say about this. The fiber reinforced polymer in concrete is like a big branch in the study of civil engineering and construction materials. Like FRP is very famous, and also it's like the initial study is in Hong Kong and in the US. And our group, although our group we haven't do a lot of things about FRP concrete, but I know that in our level in HID Shenzhen, they are big groups. They are doing FRP concrete, like they are using FRP in concrete structures. They are using it to improve the strength of concrete, like it's like using like the shell outside, and also in their group they are also using effort as reinforcement, like to replace the steel rebar essentially to improve the durability of reinforced concrete. So using the F4P reinforced concrete as fixed or loading investment in ocean engineering, they want to use this kind of technique to first of all to improve the performance concrete, and then to improve the durability performance. First is the stress performance, then is the durability performance using this polymer materials.
Thank you, Professor Gu, for the nice presentation. If you have a chance, our colleagues from the civil engineering department, they are conducting a project on steel, concrete, steel panels for producing FPSO. So they have done a large experimental campaign and numerical model as well. So it's in the Center of Technology, a couple of miles from here. If you have a chance, tomorrow, next week, and if you want to make some connection, I can put you in contact. It's a nice project sponsored by Petrobras. They are doing structural global analysis and material characterization. They did develop a special concrete for this application. So if you have a chance, I think it's very much connect to what you are doing.
Yeah, thank you.
Yeah, Sagrillo is going to be here tomorrow, but more on the numerical model. And all the experiment with another lab that they are conducting experimental tests.
Thank you very much.
No, I'm not a structural guy, so I can ask any silly question. But I'm curious about how can you be sure about the connection between the concrete and the steel in your model?
Okay, so there are different type of composite structures and different types of connectors are used in a different type of for the composite beams. Maybe we are using channel connectors, channel steel, and shear studs there. And also, like previously in my presentation, we are using angle steel and to put it in the surface of the steel plate to improve the connections between steel and concrete. But in the concrete field steel tubes, like the columns, the basic nodes it's facing to is like the compression and maybe a little bit moment. And the study has already proved that the fraction in the surface between steel and concrete already meet the demand of the shear force in the interface. So it's like in composite columns. In a lot of cases, we do not need special connectors in this type of member. Thank you.
Is there any more question? Okay, thank you very much, Professor. This was the last presentation today. I don't know if Professor Sergeant would like to comment.
Tomorrow, 8:30.
Yeah, tomorrow 8:30 we're going to continue, okay? Thank you very much.